Thermal bridging is a hidden but significant issue that affects the energy efficiency, comfort, and moisture control of buildings. Whether you're a homeowner, builder, or inspector, understanding how thermal bridging works can help you make smarter decisions about insulation and construction. Thermal bridging occurs when a material with high thermal conductivity, like metal or wood, creates a direct path for heat to flow through the building envelope, bypassing insulation. These bridges allow heat to escape during the winter and enter during the summer, reducing the overall effectiveness of your insulation. Common examples of thermal bridges include wall studs, roof rafters, window and door frames, steel beams, balcony slabs. How it relates to insulation. Insulation works by slowing down the transfer of heat, but thermal bridges can drastically reduce its effectiveness. Even if you install high-quality insulation between wall studs, those studs themselves, often spaced 16 inches apart, can create consistent paths for heat to travel in or out of the structure. In fact, in a typical wood-framed wall, up to 25% of the wall area may be uninsulated due to thermal bridging at the studs. That means the true performance of your wall insulation could be far lower than the rated R value. Is it worse in wood or steel-framed homes? Steel framing is significantly more vulnerable to thermal bridging than wood. Steel is about 300 to 400 times more thermally conductive than wood, making it an extremely efficient conductor of heat. As a result, walls framed with steel can lose heat rapidly unless additional steps are taken to mitigate thermal bridging, such as adding continuous insulation on the exterior. Wood is less conductive than steel, but it still acts as a thermal bridge, especially in tightly spaced framing layouts. What happens to condensation? One of the most serious consequences of thermal bridging is interior condensation. When warm, moist indoor air contacts the cold surfaces created by thermal bridges, e.g. the inside surface of a stud or beam, the moisture can condense into water droplets. Over time, this can lead to mold and mildew growth, degraded insulation performance, structural rot or corrosion, poor indoor air quality. This is especially problematic in climates with cold winters or high humidity levels. Here are some proven strategies to prevent thermal bridging. Continuous insulation, CI. Installing a layer of rigid foam or mineral wool board on the exterior of the wall helps cover framing members and reduce thermal bridges. Thermal break materials. Use insulating spacers or structural thermal breaks, especially in steel framing. Advanced framing techniques. Reduce the number of studs and use insulated headers to minimize bridging. Proper moisture management. Include vapor barriers and allow for wall drying to reduce the risk of condensation damage. Thermal bridging is a quiet energy thief and a potential moisture hazard that can compromise even the best insulated homes. Whether you're building new or retrofitting an existing structure, addressing thermal bridges can significantly improve energy efficiency, indoor comfort, and long-term durability.